Good morning, guys. Hopefully, you guys have been doing well. I know some of us need a haircut. I definitely do. But let's get straight into it, all right? So, I just want to kind of review from yesterday. We were looking at parts of a function, parts of a linear function. So, most of what the assignment yesterday was, it was all about x-intercept and y-intercept, right? So, if we review from Monday or yesterday, the x-intercept is when it hits the x-axis, right? So we count over 1, 2, 3. So our x-intercept is at x equals 3. Sounds pretty easy. Then we have y-intercept, so I know I'm going to use y equals, right? And then I'm going to count up from the beginning, the origin, right? And I'm going to count up 1, 2. So my y-intercept is at y equals 2. Not too bad, right? We're going to move on to quadratic functions. Remember, so in linear functions, we had something like y equals mx plus b, or in standard form or any other form, right? But in terms of quadratic functions, we'd have something like y equals x squared plus something, 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 right? So the only difference between this one and this one, there's a lot of differences, but first of all, this one's a straight line, and this one looks like a boomerang, right? In that case, it's because of this x squared. That's why it looks like a boomerang. And we'll go over more into why it looks like such soon. But we're going to be identifying the parts of the quadratic function today. And if you can see, I've got 5 of them. Now I'm going to tell you, there's really just 4, but I have 5 written. Why is that? Let's see. We've got the x-intercept. This is pretty much the same thing as back here, right? You're looking at when it hits the x-axis. The only difference is that if you can see here, I'm going to look at the x-axis, right? But wait a second. It hits my x-axis here and over here. So, Mr. Chum, which one do I put? You actually put both of them, right? So this is what becomes part of the difference between a quadratic function and a linear function. Because a linear function will only have one x-intercept, while a quadratic function can have up to 2, right? Sometimes it can have 1, sometimes it can have 0. I'll go over that in a sec. So we find these two. So I've got x-intercept at 0, right? That's where I'm starting. So x equals 0. But I also have this one over here, right? So I'm going to start at the origin, then count over. 1, 2, 3, 4. So I have 2 x-intercepts, x equals 0, x equals 4. So those are my 2 x-intercepts. Now I said we really have 4 parts here, but I have 5 written. And the reason why is because zeros and your x-intercept are essentially the same, right? But that's essentially what we'll do. We're saying that x-intercept and zeros are essentially the same because it hits at y equals 0. That's why it's called a 0. All right, so let's go into y-intercept. You guys should be familiar with this one by now. We're just looking at when it hits the y-axis, right? So we're going to look at it, and we see that it hits right here. And it happens to be the same place as the x-intercept. That's totally fine. So you got y equals 0. Not too bad. So next we have 2 new ones, right? We've got the vertex here. And the vertex is the tip of the boomerang, the center, I guess. And how you would see this, well, I've got this boomerang right here. And you're looking at right where it starts to bend, right? And if you follow with your finger, you see right here, that's where it starts to bend. Or the middle of the boomerang, the center of the U, the middle, any kind of terminology that'll help you figure out this is always the vertex will always be good. All right. So what is it actually asking for then? It's asking for the coordinates of the vertex. So what I have to do is I start at the origin and I want to get to my vertex, right? So what I want to do is count on the x-axis first. So 1, 2, right? And then I have to count down. So I have to go down 2 to get to my vertex. So I went to the right 2 and down 2. So it's 2, -2 for this vertex. Now what I want to do is find the minimum or the maximum value of this function. And how do I know if it's a minimum or a maximum? Just look at your vertex, right? If I'm going to look at my vertex, is this the bottom or the top part of my parabola? If it's the bottom part, I know it has to be the minimum because it's the lowest point of this graph. If it's the top part of the graph, then it has to be the maximum. So that's how we would figure out if it's a max or min. So what is the max or the min? Well, in this case, first of all, it's a minimum because we're on the bottom, right? If it's on the bottom, I'm just looking at the value of the function at that point. So I'm going to look at my y-axis, and I'm going to look at where it hits on the vertex. So the vertex has a y value of -2. And you see that right here. If I count down 2, that's exactly where my vertex is. So I know that my min has, and this is the at symbol, min at -2. All right, so let's go on to this one. So this is one of those examples where you have a parabola, you have that boomerang shape, but you only have one x-intercept. You only have 1, 0. So that is totally fine, but we just continue as normal. So I've got this one x-intercept right here, and that's at 1. So I have x equals 1. So the thing is, quadratic functions are supposed to have 2 zeros, 2 x-intercepts. So what happened in the second one? What really happened is that this is repeated, right? And you'll see that more in Algebra 2. And technically, you do have 2 x-intercepts, x equal 1, x equal 1. But for the purposes of Algebra 1, you should be fine with just x equals 1, and it's repeated. And then we know that the zeros are repeated. Sorry, the zeros are the same as the x-intercept. So it should be x equal 1. And then we're looking for the y-intercept. Hopefully you guys are pros at this one. I'm just looking at when it hits the y-axis. So it hits right here. And I can see it matches at -1. So y equals -1. Cool, cool, cool. Then we've got the vertex. Now the vertex, remember, that's where you're looking at the boomerang. And I'm going to look and to see where it starts to bend, right? And that's where it really starts to bend right here, this point. So that's good. Now we just have to find the coordinates of the vertex. So I start at the origin, 0, 0, and then I get to my vertex. All I have to do is move to the right, 1. I don't have to move up or down, so all I have is 1, 0. All right, then we have our minimum or our maximum. And remember, if it's the bottom, it's the minimum. If the vertex is on the top of the vertex, if the vertex is on the top of the boomerang, then it has to be the max. Well, in this case, it's on the top of it. So in this case, we've got a maximum. And we're looking at the y value. Oops. I didn't even realize that these axes switched. We're looking at the y-axis, and we're looking at the vertex. So this is at 0, so I know that my max is 0. And if you see the actual coordinates of your vertex, the maximum value and your vertex are the same. You'll see right here, same thing. The minimum value in the y value of the vertex are the same. So that's just an easy way or another way to look at things. So if you have the vertex, you already know either the minimum or the maximum value of this function. And that's pretty much it. So I just want to go over one last thing. Let's see what I want to, let's get rid of this one right here. And some of this. Just so you guys know, if you guys are having trouble or you need me to slow down, you can always pause. You can always rewind. So that's the awesome part about YouTube. All right, so I just want to go over numbers of zeros. And this is what I was trying to allude to earlier, that quadratic functions can have up to 2 zeros, or x-intercepts, I mean. So I just want to go over 2 kind of rudimentary examples. And let's look first at kind of our normal example. So this is when we have 2 x-intercepts, 2 zeros, however you want to say it. I'll just say 2 zeros. Right, so if we have 2 zeros, we know it has to hit the x-axis twice. So it could look like something like this. That's perfectly fine because it hits the x-axis here and here. That's why I have 2 zeros. Now, this is the one I was trying to look at earlier. This is where I have 1 0. And then in parentheses, I'll say 1 is repeated. So if we go here, we can have a parabola that looks like this one. Now, if you see the difference, this one just touches the x-axis and kind of bounces right off of it. It doesn't actually go through. This one over here goes through the x-axis and then back out the x-axis in a different direction, different location. And then the last one is when you have 0 zeros, no zeros. And you can have something like this. So if you guys see, whoops, this one doesn't even touch the x-axis at all, right? So if it doesn't even touch the x-axis, then there's no x-intercept. Therefore, there are no zeros. And those are the only 3 real cases that we have for quadratic functions. Once you get to cubics, it gets a little different, and all the other ones. But other than that, that's all I wanted to really go over today. If you guys have any questions, don't hesitate to ask me on Remind or Google Classroom. But other than that, have an awesome day, and I'll see you guys later.